All right, ATT, this is Mr. Johnson doing our 7A review video of the review packet. So make sure you have your review packet out on your desk. Just a reminder to pause this at any point or stop and rewind and go back, or pause and try a problem and then watch it to check your answers. Don't simply just watch this and copy everything down, but rather use this as a resource to help you practice these types of problems. So here we go. First chunk here, we are drawing rotation angles and reference angles, remembering that we've got from between 0 and 360 all around our circle here. So 0 and 360 end up being that same area there. So a rotation angle of 295 degrees is past 270. So I put my little triangle here, just kind of estimating, and I show that rotation of 295 degrees. In order to find the reference angle, or that angle inside the triangle, that's always going to be coming with the horizontal. In this case, it's going to be 360 minus 295. All right, we don't want to do anything with 270 because we don't care about this space in here. What we care about is the angle inside the triangle. And 360 minus 295 gives us a reference angle of 65 degrees there. Number 2, they actually give us a reference angle, and they put us in quadrant number 2, which is over here. So we're in quadrant 2 with a reference angle of 24 degrees. Now, in order to find that rotation angle, we have to think about, well, a full rotation over to the horizontal there would be 180, but we're 24 degrees short of that. So 180 minus 24, or 156 degrees, would be our rotation angle. And finally, 217 degrees. That is short of 270, but more than 180. So that puts us in quadrant 3. So I'm going to kind of put my triangle here in quadrant 3. 217 degrees. In this case, we're going to do 217 minus 180 to figure out kind of what's left inside that triangle there as my reference angle. And that looks to be 37 degrees, I believe, when you do that subtraction. So we get our angle. So again, just a quick reminder, if you're trying to find different angles here, in the first quadrant, your reference angle and your rotation angle are the same thing. In the second quadrant, you've got to do 180 minus your rotation angle to find your reference angle. In the second quadrant, you're going to do 180 plus that reference angle to find your rotation. And the third quadrant, I spoke that incorrectly. First quadrant, same thing. Second quadrant, when you have your reference angle, 180 minus it will give you a rotation. Third quadrant, 180 plus the reference angle will give you a rotation. And fourth quadrant, 360 minus the reference will give you your rotation angle. All right, let's do some definitions here. Sine is always opposite over hypotenuse, or in our case, the y over r. Cosine adjacent over hypotenuse, or x over r, and tangent opposite over adjacent, y over x. Keep in mind that some of these might be negative in different quadrants. So 5 and 6, these are some tougher ones. We haven't done these in a long time, so it might kind of take some review in here. So radius and rotation angle needed to move a point from the initial position, which is our starting position at 0 degrees. So I'm going to kind of draw that out here, to a point with the coordinates 10, negative 18. Well, 10, negative 18 would be in quadrant 4. I'm just going to kind of sketch a possible 10, negative 18 here. It's an x value of 10, a y value of negative 18, and my rotation angle is going to be at least 270 degrees, if not more than that. All right, so I need to find the radius, which is our r value. That's going to come from doing some Pythagorean theorem here. When I do that Pythagorean theorem, technically I'm squaring negative 18, but because these are side lengths, I'm not really worried about making that negative. So 10 squared plus 18 squared gives me my r value squared. In my calculator, 10 squared and 18 squared is a total of 424 is r squared. When I square root, I get that r is approximately 20.6. So I've got an approximate radius there of 20.6, and I like to show that that is approximate. And now we have to find our angle of rotation. Well, that comes from figuring out first my reference angle, and then I'll have to do 360 degrees minus that reference angle in order to find my rotation angle. So the reference angle can be done a number of ways. Any inverse trig would work in this case. So I could recognize that like the sine of my reference angle is negative 18 over r, which is 20.6. I wouldn't really want to use that because it uses the r value that I found in the problem. So I'd probably not do sine or cosine. Instead, they would give you a correct answer, but it is rounded. I want to be as exact as possible or as close without using an already rounded value. So I'm going to use tangent in this case because I'm provided with the 18 and the 10 that I'll use. And when I'm using inverse trig, I'm only going to use the positive values to find my reference angle. So I'm going to do the tangent of theta, which is typically negative 18 over 10. I'm going to do inverse tangent in my calculator of positive 18 over 10 to get my approximate reference angle there. And when I enter that in, that second tangent, 18 divided by 10, I get 60.9 degrees. And 60.9 is my reference angle, but then again, I need to subtract that from 360 because I'm in the fourth quadrant to find my rotation angle, which would be 299.1 degrees, again, approximately. All right, and lastly, number 6 here. We've got a crane that picks up a load with a radius of 12 feet and a rotation angle of 253 degrees. All right, that is between 180 and 270, so that's going to put us in our third quadrant. And I know the radius is 12, rotation of 253. In order to find that reference angle, I know that I can do 253 minus 180 because I've got 180 to get to the x-axis, and then I have to go a little bit further, and that would be how many degrees further? 73 degrees as my reference angle. So now I need to find these coordinates. Well, I've got a y value and an x value. It's worth noting that because I'm in quadrant 3, that x value and that y value are both negative. So your calculator is not going to tell you that, but we have to remember based on the quadrant that x and y are negative. So now I need to write some equations to find x and y. I'm going to do this using trig. For example, the cosine of 73 degrees is equal to x over r, or x over 12. Multiply both sides by 12, and I get that 12 times the cosine of 73 is my x value. So I'm going to just type that into my calculator and put it in there for x, put it in there for my x coordinate, knowing that it's negative. And the sine of 73 degrees is equal to y over 12. Multiply both sides by 12. 12 sine 73 equals y. Put that in my calculator and put that in as my y coordinate. So I'll do x first. That's 12 times cosine of 73. I enter it all together. I get 3.5. And again, that's negative 3.5 because the x coordinate is negative. And then 12 sine 73. I get 11.5. And again, negative 11.5 because the y coordinate is indeed negative in quadrant 3. So there is your final answer. Check out the other videos for 7B, C, and D. If you need more practice, please go back on the calendar and look at all the different 7A practice materials that are there for you.